into lesson 1.9 today, let's first of all, there's a couple of learning goals that we have over here on the board. I can use proportions, which we did in lesson 1.8, to solve problems involving geometric figures. So now we're going to have geometry introduced along with using our algebra. And then I can use proportions and similar figures. We're going to have to talk about that. Let's make sure we have an understanding of what similar figures are to find measures indirectly. Okay, so those are our two learning goals today. So let's first of all, let's just make sure that we understand geometry symbols. What do they mean when they show it? So we have some symbols in this table, and it's showing us which words correspond with those symbols. So when we have just a little line, it's not even really a line, it's a line segment without the endpoint shown. When we have a line segment over two letters, they're saying that is the segment XY. You can count on X being a point at one end and Y being a point at the other end of our line segment. When they have the slanted capital L in front of a letter, or even three letters, that's the angle. So this is our angle symbol, and we have to make sure that we understand how to write. If we don't want to write the word angle, how do we do it mathematically then? Triangle, XYZ. We draw a triangle and name what are the X, the Y, and the Z? Where do those come from? Just, Aaron?
That's several labels on all the triangles, or the segments of that.
At the ends of the segments that form the triangle, does anybody know another name for what those are called? What is this called right here where X is at? What's that called? Where? What is it, Manisha? Vertex. Yeah, it's a vertex. And when we talk about plural, we don't say vertexes, we say vertices. Vertices, okay? So it's a vertex. And so we name the points that are at the vertices of the triangle when we're naming the triangle. If we have just the two letters, the two endpoints of a line segment, but no line above it, this is important that we understand the difference between this and this. Here they're saying they're identifying line segment XY. In this one, they're saying, what's the length of this line segment? Give me the length of that line segment. When we put a little m in front of our angle, when we have this little m in front of it, they're asking you to give the measure of that angle. And then our little one squiggly right here stands for is similar to. So we want to make sure that we have an understanding of that symbolism. You don't say to me, Mrs. LeGrand, what does this mean? This is like, another language. Yeah, it's a mathematical language that we have to make sure we understand. Okay? So, answer each question. Write triangle ABC in symbols. Go ahead and do that in your papers right now. How would you write triangle ABC in symbols? So what would we do? If we want to write triangle ABC in symbols, no words involved, how would we write it? Tyler?
We draw a triangle and do ABC.
Yeah, we draw a little triangle and put the vertices following it, A, B, C. Okay, now we have this equation, this mathematical statement that they want us to write in words. What is that really saying? Katie?
Angle B equals 93 degrees.
Okay, well, what else? I think we should be just even a little bit more specific. What other word do you think maybe we could include in there? What's that little M stand for?
Measure.
Measure. So we're going to say the measure of angle B. We're writing in words. The measure of angle B, we're not using the angle symbol either anymore here, is 93 degrees. So we're writing a word sentence. The only thing we're not going to write out in words, I'll let you get by with not writing the number out in words. Okay, So, because we can't really say angle B equals 93 degrees, we've got to say what about angle B is 93 degrees. That's why we have to make sure we put that word measure in there. Okay, number 3. Now we have this mathematical statement that they want us to write in words. What would that one be? Brendan?
Triangle XYZ is similar to triangle ABC.
Okay, triangle X, Y, Z is similar to triangle A, B, C. Sentence. Starts with a capital letter, ends with punctuation, and we write out the words they wanted. Okay, so what does similar mean? Is similar to, what's that mean? If they're saying that triangle XYZ is similar to triangle ABC, what are they saying about those triangles? Sage?
The angle measures are the same, but the length of the segments are different.
So if you have similar figures, they have the same angle measures. They have exactly the same angle measures, but they don't have to be, so they have to be the same shape, right? But they don't have to be the same size. So we can have a very small triangle. It looks very small. It has small side lengths that is similar to a larger triangle that has a lot longer side lengths, but yet their angle measures can be exactly the same. So when we talk about is similar to, we know that corresponding angles, what does corresponding mean? Corresponding angles are the same measure. Well, now what does corresponding mean?
The same time.
Well, the same as, kind of.
Same shape and same size, same angles.
No. But how do we know they're the same? What if they're not, how do we know they're, what is corresponding really saying? Aaron?
It's like on the two triangles we have, angle Y would be corresponding to B.
Okay, angle Y would be corresponding to B, okay, and why?
Well, since they're both similar, they would have to have like the same, something.
Yeah. They have to have the same angle measure, right?
Yeah.
But why are they corresponding?
Because.
Why are they similar?
Well, if it's the same triangle, it's maybe not the same size. They would have to probably be the same.
So we're getting close, you guys. Corresponding means in the same position, in the same place, yeah, in the same place as the other figure, in the same location. So if, we have corresponding angles, when we give those angle measures in a triangle name, like X, Y, Z, and ABC, Y does correspond with angle B. Give me another pair of corresponding angles then from triangle X, Y, Z and triangle ABC. We already said that angle Y would be corresponding with angle B. Sage, what's another pair?
A and X.
Angle A would be corresponding with angle X. And what's another pair of corresponding angles? Zach?
Z and C.
Z and C. Angle Z would be corresponding with angle C. So they put the angles that are corresponding with each other in the same position, even in the name. So they're in the same position in the triangles, they're in the same position in the names, they're in the same place. So think of corresponding as in the same place, in the same position. Okay? So use the information given in the symbols below to label the diagram shown above. Okay, so what's this one say right here? What's this one saying to us? What's that one saying?
Measure of angle X
The measure of angle x equals
equals 38 degrees.
38 degrees, so we're going to go inside of angle x and we're going to put a 38 degrees. Okay, and then it says, let's do this one. Let's just keep going here. Measure of angle B is 93 degrees, so we're going to go up and put in this one, we're going to say up here in angle B, it's a 93 degree angle. And then they give us the measure of angle C. They say that one is 49 degrees. Okay, so we've taken care of those top three. Okay, what's this saying? What's this saying now? Tyler?
The length of the segment
is 18 centimeters.
The length of segment XY is 18 centimeters. So we're gonna go up to XY and we're gonna put in 18 centimeters along between the two endpoints. Okay. Go ahead and do the other two now, because the other two are lengths also. We have the length of YZ. And BC. Okay, just like there are corresponding angles, there are also corresponding sides. Okay, so let's answer these questions now. What would be the measure of angle Z? What would be the measure of angle Z? Did they give us that one?
No,
No. Could we get it?
possible.
Possibly. Okay. How are we going to get it? Find its corresponding angle. And didn't we already identify the corresponding angles?
C.
Which one did we say corresponds with Z?
C.
C. So did they give us C?
40.
Yeah, they said it's 49 degrees, so guess what? The measure of angle Z also has to be 49 degrees. So let's go up and put that in our drawing. That Z is also 49 degrees. Okay, well then they say what's the measure of angle A?
38.
It would be 38 because why?
It's the same as X.
Because X is 38 and they are what kind of angles?
Corresponding.
Corresponding angles, so we could say that one's 38 degrees. And so we'll go up to A and we'll put in that one, we'll put that, we have a 38 degree one. Okay. So, what's the next thing they want us to do? Write a proportion relating AB, BC, XY, and YZ. So there's several different ways we could show a relationship between those four line segments. Their lengths, that's what it's asking for. Write a proportion showing the lengths of those four line segments in relationship to each other. Okay, so does somebody want to offer up one they think would work? A proportion model that would help us show the relationship, the length of AB, the length of BC, the length of XY, and the length of YZ. Could we do corresponding sides in one ratio? Could we do that? Okay.
Probably
What side would correspond with AB?
X, Y.
XY, because AB are the first two letters in
A, B, C.
triangle ABC, and XY are the first two letters in triangle XYZ, so they're in the same position, they're in the same place, that means they correspond. Let's do that ratio then. Let's say that we could set up AB over XY. Well then, we have to use the other two in the ratio, but we gotta keep a good relationship here. So we have BC left and we have YZ left. So what order should we put that ratio in?
XY over YZ.
We already used XY, we don't want to use that one again. We're done with that one. What would we have to do it? Now that we've started this way, there's only one way to do it. How would it have to be now? Aaron?
Y to 0 over BC.
YZ over BC? Okay, let's put it there and let's take a look at that. Is that a good relationship?
Yeah.
So we have corresponding sides. I agree with that. But what's the problem? Upstairs, we're working with two different triangles. Downstairs, we're working with two different triangles. Can we do that? No. Vertically, we're keeping the corresponding sides relationship, but horizontally, we've lost the triangle within one triangle relationship. So we have to reverse those. They have to go the other way around. Important that we set up the correct order. So we have to put the BC upstairs because it comes from the ABC triangle like the other ratio upstairs, and the YZ is going to have to go down here. Now again, this is not the only correct way to set up a proportion model for this. Anybody think they know another one? John?
AB over BC is equal to XY over YZ.
Okay. That one would work also. Are there any others that would work?
You flip them.
Sage?
You can just switch them around and put BC over AB and YZ over XY.
BC over AB, and what would be the other side then?
YZ over XY.
Yeah, we could do that.
You could just flip the order. You can have BC over YZ is equal to AB over XY.
We could have BC over YZ is equal to AB over XY. I bet there's, a few ways, but are there some incorrect ways?
Yes.
Yeah, we already tried to set it up incorrectly once. We decided we probably shouldn't do that. Okay, let's work with this one. Let's work with our first one that we did, okay? It says, substitute the known values into the proportion from problem 7. So here's our proportion. And then solve it to find AB. Okay, let's write it down here first of all. We're going to use this one because we have several there now. So we're going to use that one and we're going to substitute into it. Okay, do we know the length of AB?
No.
No, okay, so we'll just call that one AB. We'll just leave it AB. It's okay. Or you can call it X if you want. Do we know the length of XY?
Yes.
What is it? 18. Do we know the length of BC? Yes, it is 10. Do we know the length of YZ? Yes, it is 15. Okay, now I have some lazy people in here. This is what I'm starting to see. It goes from this to the answer. And what I mean by lazy is I'm not saying you're not doing the problem. I'm saying you're just not showing the steps of work that you're supposed to be showing. So if we change this to X, it actually makes it a little easier for showing the work. So we're going to do 15 times X, which is 15X. 18 times 10, which is 180. We will do what next? Divide by 15 on both sides. And we will show that our final answer becomes X equals 12. And we're going to actually now rename it as the length of AB is what? 12 centimeters. We know they're measured in centimeters, so we have our... Now, could we have done that just from our drawing before, not found another way to get this answer without setting up the proportion? In other words, could we have just looked up back up here and said, well, that side corresponds with, this one, so it has to be the same length. Which side does it correspond with again?
YX.
So XY. So should we be able to say that because they're corresponding sides? Why didn't it turn out to be 18?
Because it's smaller.
They're similar.
They're similar. They're not the same size. They're just the same shape. They have to have, so this is important that we catch this. Sometimes students miss this part. Similar figures always have the same angle measures, but they don't always have the same side measures. Can they have the same side measures? In other words, if you have two figures that are exactly alike, are they still similar to each other? Yeah, they're similar and they're the same, aren't they? They're kind of both. Okay, so we have to make sure that we understand this because you're going to do some of this stuff in your homework. Is there any questions? Okay, then let's go to the back, where now we'll use our amazing knowledge. Okay, what does that say? If what?
Triangle ABC is similar to triangle DEF.
Okay, so they're saying to you, if. In other words, if this is the case, we're telling you that we're going to let these guys be similar triangles, then I'm saying, here's what I want you to do. I want you to tell me then the measure of angle A would be the same as the measure of angle what? D. Okay. The measure of angle B would be the same as, it would equal the measure of angle E. And the measure of angle C would be the same as the measure of angle F. Okay. So these are thoughts we need to have. Now I want you to set up, this is going to be, we can't call this one a proportion because we're gonna set up 3 ratios and just showing that we have corresponding sides, ratios of corresponding sides equal to each other, okay? So what side does AB correspond with? DE. What side does BC correspond with? EF. And what does that leave for us? What other set of sides do we set up a corresponding side relationship with? CA corresponds with FD. Okay. So what I want us to put there is I want us to realize that what we have here is when we talk about the ratios of corresponding sides, and I want you to write this, ratios of corresponding sides are the same. They are equal to each other. So when you set up ratios of corresponding sides and divide them out, you should get the same value every single time. If this is a 20-sided set of similar figures, you can set up 20 ratios of corresponding sides. And when you divide every one of them out, it should give you the same value every time. Okay? So we don't have any information yet to know what that ratio would be, but I'm going to guess we're going to, do it in another one here. So we have MNOP is similar to WXYZ. What kind of figures are these? Are these triangles?
No.
What are they?
Rectangles.
Do we know that they're rectangles for sure?
No.
Segments.
No, they're not segments and they're not, what did I just hear something about quadrilaterals? Yeah, they're quadrilaterals, okay. So we have, let's put that here. We have quadrilaterals. We know that much, that's the best we know right now. We know we have quadrilaterals, we don't know if they're rectangles, we don't know if they're squares, we don't know if they're a rhombus, we just know that they're a 4-sided figure. How do we know that?
Because there's 4 angle measures.
There's 4 angle measures, or in other words, there's 4, what did we say?
Vertices.
Vertices. There are 4 vertices. That's how we know it's a quadrilateral. Okay, so this says if the measure of line segment NO is 2 centimeters, and the measure of XY is 2.8 centimeters, and the measure of ZW is 7 centimeters, find PM. Find the measure of PM. So you go ahead and set up a proportion that will help you solve that. Set up a proportion that will help you solve that. I would suggest you set up ratios of corresponding sides, like we just practiced in the one above. And the first thing I always do before I use the numbers, I use the letters. I set up a proportion using the letters to make sure I have a good relationship. I don't even deal with the numbers right away. Okay, you guys are working away and you haven't even verified that you have a good proportion to start with. Anybody have my model? I have no numbers in it, notice. No numbers. I'm not going to mess with numbers until I'm sure I have a good relationship set up. Okay, I got some people who like mine. Okay, let me hear some others then. Letters. I don't want numbers, I want letters. Let me hear another one. Stop those pencils. If you don't have one by now, then tough luck. Give me another example. There's only about 6 people who agreed with mine. So there must be another way somebody else set it up. Zach.
I have NO over XY equals UW over P.
Okay, how do you feel about that class? Is Zach going to be successful with that one?
No,
Okay, what happened?
he didn't put them in right.
He lost the relationship between the
between the quadrilaterals, didn't he? This one comes from the first quadrilateral, or the second quadrilateral, this one comes from the first, and so we have the correct relationship. We don't even have the correct relationship vertically, do we? NO comes from the first quadrilateral, and XY comes from the second. So we have to keep the relationship. We have to, if vertically or horizontally, whichever way we do it, we have to keep the corresponding relationship, and we have to keep from the same figures. So we're going to have to toss that one out. Sorry, Zach. But thank you for offering it up, for being so bold. Okay. Brendan.
As O over PM is equal to XY over ZW.
Okay. How many of you think Brendan could be successful with that one? Yeah, some works too. Anybody have this one like Brendan did? Yeah? Okay. Are there any others out there? There are other ways. This is not the only two ways. We've discovered two good ways. One that we had to throw out. But we have to make sure we know how to set up a good relationship first to get the right answer. Before you even put the numbers in. So no other choices out there? I love getting incorrect ones too. It's okay. Because we need to know that there are ones we can't accept. So do we have any others out there? Okay, then I guess we'll plug in some numbers now. Now use the one that you want. Plug in the numbers and find out the length of PM. Okay, go ahead, Brendan, what's the answer?
X equals 5 centimeters.
5 centimeters. Okay, so, but I'm not going to put the centimeters on that yet because I need to say
PM equals 5 centimeters.
the length of PM. Remember, that's how we say it, right? The length of PM is 5 centimeters. Yeah. Okay. So we have to set up a good relationship. When we are done, we should be able to. And sometimes you know what it might even help you to do. Draw a picture. You don't know what this quadrilateral its real shape is, but that doesn't matter. You could go like this. You could say, I have M, N, O, P. By the way, we always stay in order. You're either going clockwise around. That'd be counterclockwise for you guys. You're either going counterclockwise around or you're going clockwise around. You don't jump corners and play, jump around. And then you could draw another one. It appears that this is the bigger one, so I shouldn't have made that one quite so big. But then just draw the other one and say X, Y, or no, W it started with. I'm sorry. Okay, so W, X, Y, Z. And then when you have the picture, sometimes that helps you be able to see the relationship better. And then you could label the side lengths on it, and it'll help you be able to set a proportion model better. But here's what I'm going to see you guys doing. You're going to give me the numbers right away in a proportion, you're going to solve it, and you're going to be happy that you have an answer. Pretty much. And not worry about whether you had a good setup to begin with. And then we just are going to keep getting wrong answers when we don't need to. Okay? Anybody have questions about it? Okay, it looks like you need to turn to page 70 in your textbooks. Page 70, where we're going to use indirect measurement to find an unknown length. And we're going to go to the check it out on that page, 2B. Okay, we have a woman who is 5.5 feet tall that casts a shadow 3.5 foot long. At the same time, a building casts a shadow 28 feet long,
Write and solve a proportion to find the height of the building. Now, up above in example 2, they show an example of using indirect measurement. When we use indirect measurement, what we do is we set up a right triangle relationship and then do just what we were doing here, set up a relationship with corresponding sides in a proportion and solve for the missing thing. So we're going to draw a picture. We have this woman, and we're not going to, you don't have to draw an actual person. This woman who is, how tall is she? Okay, would you do this with me? This is what I expect to see in your homework too. She's 5.5 foot tall. She casts a shadow. Well, this would be her shadow, wouldn't it? Right here?
Yeah.
How long is her shadow?
3.5.
3.5. And it's shorter than she is, so we're going to make that a little bit shorter. We don't have to be, do anything scale drawing here. And now we're going to just connect the vertices to show, because when I'm standing at the ground, my feet should be making a right angle, my body should be making a right angle with the floor, shouldn't it? So we actually have a right angle here. And that's important because we need to create similar figures to be able to use this indirect measurement. Okay, then what do we have? We have a building that is, we don't know how tall it is? Okay, so what should we call that? X. Okay, so the building is X feet tall.
Cast a shadow of 28 feet.
And how long is its shadow?
28 feet.
28, okay, so we have a 28-foot shadow here. And would a building, if it's a good building, would it make a right angle with the ground?
Yeah.
Yeah, hopefully. Otherwise there might be eventually some trouble, right? Okay. So we now actually have, because this is at the, it's at the same time of the day, so this angle measure, these two angle measures are the same. The sun casting down and making this shadow makes these two angle measures the same, because it's at the same time of the day. Well, that means the third angle in each of them has to be, right? Because there's 180 degrees. And if they both used up 90 of their 180, and they both used up whatever that angle is up at the top, that's the same. They both have the same amount left over for this one down here. So we have similar figures. So now let's set up a proportion that will help us solve for the building's height. There's several choices that are correct, several choices that are incorrect. What would be a correct choice? Tyler?
5.5 over X, and then 3.5 over 28.
Okay, what do you think, class? You agree? So the person's height corresponds with the building's height. The person's shadow corresponds with the building's shadow. Good setup? Okay, let's solve it then. Showing work first. I don't know how your I know what your calculators are for. You're going to take 28 times 5.5 on your calculators, don't you? Blake, are you willing to tell us how tall this building is?
44 feet tall.
It is, exactly. Thank you. 44 feet tall. Okay, we have a 44-foot tall building here. Does our answer make sense? And don't tell me yes it does because I did the multiplying, I did the dividing, and this is what my calculator gave me. Why does it make sense?
It's more than the shadow.
Because it's more than the shadow. And what was true about the person?
That it was smaller than the shadow.
They were taller than the shadow. So we're feeling pretty good about this because we have a number greater than the shadow for the building, right? So that makes sense. Okay. So questions at all?
Can't get out some loose leaf.